This problem says an 80 kg passenger in an SUV traveling at 1,000 kilometers per hour. Oh, this is a typo. You're not going at 1,000 kilometers per hour in an SUV. So we'll change that. We'll make that 10 squared. We'll make that 100 kilometers per hour. So let's say we'll change that to 100 kilometers per hour, which is a more realistic speed, and this is equal to 100 into 1,000 meters divided by 3,600 seconds. So the speed in meters per second is 27.8 meters per second. So now the driver slams on the brakes and the SUV stops in 45 meters. That's roughly half a football field length. Find the force that the seat belt exerts on the passenger. So there's this passenger that's going at 27.8 meters per second, and brakes are applied and the passenger stops over a distance. The seat belt applies a force in that direction and the passenger stops over a distance of 45 meters. Okay? So let's find out what is the acceleration of the passenger. V naught squared plus 2ax minus x naught. Yeah. So that's the x direction and so on. Okay, so the final velocity of the passenger is 0. Initial velocity is 27.5 meters per second. There's the deceleration, and this is 45 meters. You stop over 45 meters. Okay, so 0 equal to 27.5 squared plus 2a 45 meters. Everything is in SI units. So a is minus 27.5 squared divided by 2 times 45 meters per second squared. Okay, so the acceleration is minus 8.4 meters per second squared. And again, I'll write this as g minus 8.4 meters per second square, g divided by 9.8 meters per second square. So what this is equal to 0.86 g. So what this number means is when your weight is mg, and you would, if you jump off a wall or something, your acceleration would be g. Anyway, so the seat belt is applying a force 86% your body weight in the opposite direction. So that's what that number means. Okay. All right. Let's actually calculate the numbers. So okay, so the seat belt, to stop you, applied a force of 86% your body weight. Anyway, so let's calculate the stopping force. Find the force of the seat belt on the passenger. So that force of the seat belt would be the mass of the passenger times his acceleration, and the mass of the passenger is 80 kg, and the acceleration is, okay, well, we are just calculating the magnitude. We know that the acceleration direction is toward the left, so the acceleration is 8.4 meters per second squared. So this is 672 newtons. So that's the force that the seat belt exerts on the passenger.